Hello, good evening. This is Dr. Astik Biswas from Aviation Engineering College. Myself from EC department. In this session, I am going to explain the basic concept of timing diagram of 8085 instructions. Uh, Let me share the PPT first. So, what is timing diagram? It is the graphical representation of an instruction data flow at which step which operation is going on inside the 8085. If we want to show that, then we adopt this timing diagram concepts. This is the pictorial view of the operations of the 8085. This is the control signal or status signal of 8085. So at first, what is status signal? In the modern era, nowadays we use Facebook, Twitter, Instagram to share our moods or share our thoughts. Each in which we are going on, we share our opinion on the social media. Similarly, 8085, which operation is going on, if we want to check that, so we need to check these three lines of 8085. First one is IO bar. This is for the IO or memory operation is going on. Since status line 1 and status line 2. And there are various combination we can see. If 000, then halt, no operation is going on. Then 001 memory write, 010 memory read, and so on. We need to remember these status signals. Instruction cycle. The time required to execute an instruction is known as the instruction cycle. If an instruction cycle consists of 7 time states, we are coming on later on that, then if the operating frequency of 8085 is 2 megahertz, then to complete the instruction is microprocessor will take 7 into zero point 0.5 equal to 3.5 microsecond of time. This is known as the instruction cycle. This is a machine cycle. The time required to access the memory or input output device is known as machine cycle. And instruction cycle consists of 1 to 5 machine cycles in 8085. Then time state. This is the smallest subdivision of system clock period. If operating frequency is 2 megahertz, then t equal to 1 by f means 0.5 microsecond. So this is the one time state. This is the falling edge or negative edge. This is for this line is inclined because of this it represents the propagation delay, and this is known as the one time state. And an instruction cycle consists of maximum of 18 time state in case of 8085. The machine cycle of 8085, there are basically 5 types of machine cycle. Opcode phase cycle. An opcode phase cycle always took 4 time state in case of 8085, except 2 or 3 instructions. Those instructions are 16-bit, means DCX, 16-bit operations, means DCX, INX. These instructions are to 6 time state because this is the register pair operation, and that's why it is took 2 time state extra to perform the operation. But maximum in the general case, all the opcode phase machine cycle will always consist of 4 time state. Next, memory read cycle, memory write cycle, IO read cycle, and IO write cycle. All these cycles consist of 3 time states. These machine cycles of 8085, the processor takes a definite time to execute the machine cycle. The time taken by processor to execute a machine cycle is expressed in T states, as we discussed earlier. And it is important, one time state is equal to the time period of the internal clock signal of the processor. The T state starts at the falling edge of a clock. You can see that this T state starts of a falling edge of a clock. This is the basic diagram of opcode fetch machine cycle. If we able to understand one operation, one timing diagram, then where we will be able to understand any instruction cycle, any timing diagram of any instruction of 8085 and for the advanced processors. The opcode fetch machine cycle basically consists of 4 time states. Why 4? I am explaining later. So, and as we know, 8085 consists of 16-bit address bus and 8-bit data bus, and lower order address bus is multiplexed with 16-bit 8-bit data bus 87 to 80 naught, and a 15 to 8 represent the higher order address line. Assume the 8085 want to read a instruction from a memory, and the instruction is saved at the memory location 2000. Then 20 is the higher order, 20 is the higher order, and 00 is the lower order. So for the higher order address 20 will be available on the higher order memory line or A15 to 8 line for the first 3 time step. This is general theory, and we need to remember that. It is always true for the any subsequent machine cycles of the 8085. So we need to remember the higher order address will be available on the higher order address line for the first 3 time step. As we know, the lower order address 87 to 80 is multiplexed. So at first, to supply the lower order address line, 8085 has to demultiplex this line. So ALE signal always goes high for the first time state of any machine cycle, and for the subsequent T state T2, T3, and T4, it will remain low. Okay. So when ALE goes high, this line will be worked as the lower order address line, and 00 will be placed on the lower order address line for the first time step only. Why? Because ALE goes high for the first time state, so lower order address will be available or last on the lower order address bus for the first time state only. Next, this is opcode fetch machine cycle, means this is the memory read cycle. This is instruction read cycle, and instruction is always saved in the memory. So this is the status line IOM bar S1 S0. Simply we can see show that line that a way, means this is the 0. We need to show this line goes low for the entire machine cycle, and it indicates this is the memory operation because M bar. And this is a read cycle because microprocessor want to read some instruction from the memory and want to decode that, and instruction is always saved in the memory, and we need to read the instruction. So 8085 will insert a readable line for the second and third time state only. And we know as a human being we can't read or write at same simultaneously. So any microprocessor can't read or write simultaneously. If this readable line goes low, at that time writable line should be in high. And if and vice versa also is true. If writable line is low, then readable will be high. So it is a memory read operation. So readable line goes low for the second and third time state. Why second and third? Because 8085 has the full 16-bit address after T1 onwards. So in T2, T3, it goes low for the second and third, and that time the opcode will be placed on the data bus for the second and third time state. So up to T3, the instruction read is complete. Now the next operation microprocessor has to perform to decode the instruction. In which instruction is microprocessor need to understand the, as when we read something, at first after reading that our brain decode the text or decode the concept. Similarly, after reading the instruction, like in T4, microprocessor will decode the instruction. That's why T4 is known as the opcode fetch, or is opcode fetch time state. Okay, so for the first machine cycle or for the opcode fetch machine cycle, microprocessor 8085 will take 4 time state generally. Like we said earlier, some instruction for register pair operations, some microprocessor will take 6 time states. I'm not going into that. I will right now in this session I am discussing only the instruction that consists of four time states. Okay, so I'm repeating once. A15 to 8 higher order address line. Uh, Higher order address will be available on the address line for the first three time step. Next, lower ALE goes high for the first T1. Next, in that at that time, lower order address will be available on the address bus for the T1. Next, IO line goes low because this is a memory read operation and instruction is always saved in memory, so it has to be memory read cycle. And the read bar goes low for the second and third, and T4 for the opcode fetch. And opcode fetch machine cycle, each instruction of the processor has one byte. Opcode is a one byte. Opcode is stored on memory so that processor executes the opcode fetch machine cycle to fetch the opcode from the memory. That's why it is a memory read machine cycle I stated earlier. This is the memory read machine cycle. This is not opcode fetch. This is the memory read machine cycle. If we need to simply read some data from the memory, then what will be the timing diagram? Everything will be same except there is no T4 time state because we microprocessor don't need to execute the decode the opcode. So microprocessor doesn't perform the T4 time state. Only T3 is sufficient, and rest of the theory is always same. Higher order address line will be available for the three time state, as we say. Then lower order ALE goes high for the T1. Then lower order address will be available on the address bus. Then data will be available on the address bus for the second and third time state because read bar line goes low at that time. IOM bar line goes low for the because memory read. So IOM bar line will remain low for the entire machine cycle. So if we, as example, if operating frequency is 2 megahertz, then to complete this machine cycle, memory machine cycle, 8085 will take 3 into 0.5 means 1.5 microsecond of time. Similarly, memory write instead of read bar, it will be write bar, and rest of the pictorial view will be same. In case of IO, because we know IO for 8085 use 8-bit address for IO operation. So for the 8-bit address, suppose address any device IO device address is 80, then it is better to show the address 80 on the both of the higher order as well as lower order, because it is shown like that because I can connect the higher order address bus to any IO device, or we can app A7 to A0 to any IO device. So we have for a option we need to show the same address on the higher order as well as lower order line. Every, Everything will remain same except this is the IO operation of, so better to show like that. IO line will be even high, and this read operation read bar line goes low for the second and third. IO write same thing, only instead of read bar show write bar, and the rest of the thing will remain same. This is the example instruction of MVIB 43. As we see, this is a 2-byte instruction. This is for opcode. This is for data. Assume this opcode instruction is saved in memory location 2000. 2000 in memory location 2000 opcode is saved, and in memory location 2001 43 is saved. At first, let us process this part only in MVB. This is the opcode fetch machine cycle, so it will take 4 time step. Higher order 20 remain for the 3 time state. Lower order ALE goes high for the first. 00 will be available on the lower order line for the first time state. Read bar goes low for the second and third. IOM bar line goes low for the entire machine cycle. And data opcode is 06 opcode is available only at this bus for the second and third, and T4 will decode the instruction. So this part is over, but the task of the instruction is not over, because our main aim to move the data 43 to register B. So only opcode fetch is done. This operation is not completed yet. So we need a additional three time step, T1 to T3 or T5 to T7. It is your choice. What will you say? Better to note it T1, T2, T3, because I always because it will help you to draw the diagram more properly. Opcode fetch machine cycle only take 4 times state, and the subsequent machine cycle of any instruction will always take only 3 times states, because T4 is only for the opcode fetch. In the subsequent machine cycle, microprocessor doesn't need to decode any data. Decode or opcode phase is only being done for the first time state. For in the second machine cycle, this 43 is being read from the 8085 memory. So 2001, this thing, data 43. IOM, this is entirely because 43 is also the instruction is saved in memory, the whole instruction. So memory line goes low, the read bar line also remain low. This 7 times total will be like 4 plus 3, 7 times state. For example, if microprocessor operating frequency is 2 megahertz, then to complete the entire instruction, microprocessor will need 3.5 microsecond of time. This is the T1 to T7, or you can say these two machine cycle will complete one instruction cycle, and T1, T2, T3, T4 is time state, and this M1 and this is M2. So total there is a two machine cycle, means two different operations of to complete an instruction. So instruction cycle is whole from T1 to T7. Machine cycle M1, M2, and total there are a total of 7 times state. I think this session will help you to understand the basic concept of timing diagram. In the following sessions, I'll cover up the timing diagram of the typical instruction of 8085. Thank you.